how it relates to immunity. Now, it takes quite a bit of time for those B and T cells to produce enough antibodies to actually be effective. This response time takes a little while in order for it to go and help your body fight off those pathogens. How long do you think it takes so you guys start to feel better when you get sick with something like the flu? Sometimes a week or two, yeah. I got a student in my 5th grade class, I haven't seen her for like 10 days, poor thing, because her immune system is taking a long time to rev up, get enough antibodies out there, and fight that infection that she has. Good, 10 seconds. Alright, so what happens to you guys the first time you get exposed to a new pathogen, like a virus? Yeah, you get sick. There's many different symptoms you can get, but at the end, you're just not going to feel your best. But what happens if you get exposed to the same pathogen a second time? Your body will be ready for it. Really spoken. Try to add some more to that. Excellent use of the academic vocabulary. Your B cells will be ready for it because the B cells are going to remember who that pathogen was, and they're going to be able to make a response very quickly. Now, the first time you get sick, it takes a little while for your immune system to be able to make a response. And it's usually not very strong. But the moment that invader comes back into your system, those B cells, as Shmai pointed out, are going to be ready for it. We're going to pull it out of that filing cabinet, take a look at that criminal invader, and we're going to quickly make antibodies to go and destroy it. In fact, this might happen so quickly that your body never feels any symptoms of being sick. You might have no idea that you ever got attacked in the first place. You have immunity for life from many pathogens that you have been exposed to in the past. 10 seconds. All right, so today I'm going to talk to you guys about 4 different types of immunity, making it so that you will not get sick, or especially die, from one of these many different types of pathogens. They're in 2 categories: active immunity and passive immunity. Active immunity is when those lymphocytes are activated by those antigens, and you are able to make those antibodies to stop that pathogen in its tracks. And there are 2 types. There's natural active immunity, and then there's artificial active immunity. Drake, could you please tell us what is an example of natural active immunity? Yeah, so when I get sick with something, I'm going to acquire a natural active immunity against that pathogen for now and into the future. Roberto, could you tell me an example of what an artificially active immunity is?
A vaccination.
Vaccinations, yeah. So with the vaccination that we'll talk about soon, vaccinations are when you artificially put those antigens in your body and they train your immune system so that they know exactly who to go after. That is what vaccinations are. And we're going to be exploring that a little bit more today. Any questions?
No.
So I'm going to ask you guys questions on the quiz tomorrow, for instance. What is an example of natural active immunity? What would you say? Natural active immunity. What would be an example of artificial active immunity? Vaccinations. Good. 10 seconds. And go. All right, the next type is a little more interesting, I think. This is passive immunity. Now, passive immunity isn't forever. It's really only temporary. You only have passive immunity for a short amount of time. And there are two types. There's natural and artificial, once again. And for both of them, you have to get the antibodies to fight off these pathogens from a different source. Sometimes a person, sometimes an animal. So let's look at natural passive immunity. How can you naturally get the antibodies from someone else? What's a natural source of antibodies that you can get into your body? Annabella? What? Natural passive immunity. What's the way you can naturally get antibodies from someone else into your body? No, not passively. Check out your notes that you're writing down. What's an example of natural way to get passive immunity? Do you want to go ahead and pair share with Maria next to you? Tell talk to her. Oh, excellent, yes. Mother to fetus. Yeah, when you're inside your mother's belly, there are still pathogens that want to eat you. And unfortunately, being a young fetus, you don't have any B or T cells yourself to know how to fight all these invaders. But your mother does. She's been exposed to many different pathogens throughout her life. And sure enough, she is producing continually lots of antibodies against those invaders. Even if she gets it or does not, they're still in the system. And they will travel to you from the placenta and the umbilical cord right into your own bloodstream. Now, there's another way though, this is more interesting, about how you can go and get your mother's antibodies, even after you were born. Any know how you do this? Lucky? Eating the stuff that she's eating? Yes, indirectly. What's a better example, Rosetta? Breastfeeding. That's right. When babies drink their mother's milk, a lot of antibodies are found inside of it. And you are passively getting antibodies that way. Here's something interesting. A study came out just a few months ago that said that young children who breastfeed from their mother up to the age 5, there is statistical evidence to suggest that those who are breastfeeding to age 5 end up with a higher IQ and better physical health than those who are bottle fed. They even make more money in the long run too. Why? Why would people who breastfeed, or get breastfed I mean, have a higher IQ and higher and stronger physical bodies? Yeah. Who do you think gets more sick? Those who are drinking milk from their mother or those who are bottle fed? Bottle fed. Yeah. Yeah. There's a lot of evidence to support this. Because those who are children developing, not getting sick as often, can spend more time developing their brains, their bodies, and they're more likely to be healthy than those who are bottle fed. Food for thought. Now, this is natural passive immunity. I got one more, last one for you guys. This is artificial passive immunity. D, what is an example of passive artificial immunity?
Injection of antibodies.
Injection of antibodies. Excellent. Now, that's kind of weird. How do you get injected with antibodies? Where do they come from, you think? Needles. Yeah, I know. I hate that. They come from needles. But this technology of being able to take antibodies from someone else is huge. It's revolutionized the way that we can do modern medicine. Let me explain to you how. Do you guys remember we learned about Ebola back last spring? Yeah. Man, Ebola is a pretty bad disease, right? I mean, it really kills you when you get it. But in the population, there are a few people, luckily, who have got a pretty good immune system, and they happen to have an ability to fight off Ebola. What do you think they're producing to fight off Ebola? Antibodies. Now, when someone else gets it, it's a good chance they're not going to be able to produce the antibodies fast enough, or even at all, to fight off the Ebola virus. That's why it kills you in the end, right? It takes over and destroys all of your red blood cells. But here's what they discovered. They found a way that those few individuals who survived Ebola, Tatiana, you are an Ebola survivor. Congratulations. I hope it's okay, but you have inside of you the cure for Ebola. Is it okay if I take some of your antibodies and give it to Jim, who just got sick and has a good chance of dying from it? Would that be okay? So I'm going to go over to Tatiana. I'm going to take a plasma sample. Where's plasma found again? In your blood. So I'm going to take some of that plasma from Tatiana's blood. And in that plasma, there are billions of antibodies. Now Jim, who just came back from West Ivory Coast, I'm going to inject this serum, that's what we call this plasma with antibodies, into Jim. And those antibodies are going to kill off that Ebola virus, keeping you alive. Now, do you have permanent immunity from the Ebola virus?
No.
Why not?
It's not his.
It's not his. It's not Jim's antibodies. They came from Tatiana. And Tatiana, she produces those antibodies herself. Does she have active or passive immunity?
Active.
Active.
Yes.
She is active. Tatiana's active. Jim has passive. Excellent. I got one other example for you guys about passive immunity. Who here has ever heard of snake antivenom?
Oh, I do.
Yeah. What does that snake antivenom do? Right? Yeah. Excellent. So, there's a lot of snakes in California. What's the really nasty one that can kill you here? Rattlesnakes. Yeah. Who has ever seen a rattlesnake before? Yeah. Well, do you guys know that just the other day, Alex was walking on by and he saw a rattlesnake, and Alex thought it'd be fun to kick it in the face. Probably not the smartest decision, right? No, it was not. But, so Alex at the turn, he got bit by the snake. Now, Alex happens to have the ability to make something that can fight the toxin inside that venom. He has the ability to make an antitoxin. What class do we make that's an antitoxin? Antibodies. But here's the problem though. How long does it take to make antibodies?
Long time.
Takes a couple days. Now, when Alex got bit by the snake, does he have a couple days?
No.
No. He's only got a couple hours maybe before that venom starts to rip apart his skin, his muscles, his blood. Oh man, it doesn't look good for your future, my friend.
Oh, yeah.
But I have a solution. What if I got the antibodies from something else? That could go inside of you and neutralize that toxin from killing you. Good plan, right? So how can I get these antibodies? From Lucky. Lucky, we don't normally go and get antibodies from humans. Instead, we often get them from animals instead. Because there are certain animals, say like, I don't know, big horses. Horses actually, I don't know why, they have a great ability to make antibodies against rattlesnake poison. And so, when I have a horse, can we my horse? Thank you, Roberta. Thank you, Roberta. All right, so who's ever seen like a nature video where they're milking the rattlesnakes?
Oh, I do.
You ever wonder why they do that?
To get the venom.
To get the venom, of course. But what do they do with it? Well, let me tell you what they do with it. They take that venom that they milked from that snake and they inject it into a cow or a horse in this case. Now, oh, that sounds awful, right? Probably not what our horse would love to have happen to it. Probably not. But it's a big horse, and this horse can handle it and survive without dying. But what it does after a couple days is it's going to produce lots of antibodies. The antibody is going to neutralize that toxin, and it's going to be found all throughout its body. Now, what I can do, another big needle, sorry, I'm going to actually pull out a big chunk of the plasma from Roberto, our horse, filled with those antibodies. Now with that, I can, purify it, get the antibiotic concentrate as much as possible, so that my poor rattlesnake victim, Alex over here, I can inject this into you, so that that antibody from our donor can now be inside you to go and stop that toxin from ripping your body apart. Class, what type of immunity did I just give Alex? Passive immunity. Is it artificial or natural?
Artificial.
Artificial. Good job. All right, so just to recap. What's an example of active artificially acquired immunity? Active artificial. What's an example? Juan.
Hold on. It's an active artificial. Isn't that I don't know. A shot?
Shot. So what's in that shot?
Huh?
What's in the shot?
Vaccination.
Vaccination, sir. Excellent. All right, next question. What is an example of passive immunity that's naturally acquired? Breast milk. Excellent example. So you guys are going to need to go and be able to give me an example for each of these tomorrow.
That's easy.
Good? Yeah, easy breezy. Okay, we're talking a lot about vaccinations. Now I'm going to teach you exactly what vaccinations are. Francisco, I haven't called you in a while. Could you read out loud for us? What is a vaccination?
A preparation containing antigenetic material.
Excellent, sir. Antigenetic material. Interesting. So where can I get this antigenetic material? Well, there's a few ways. First off, I can put, a whole organism inside of you. What's going to happen if I put a whole live organism inside of you? You could die, maybe. But one thing's probably for certain. You're probably going to get sick. Exactly. So it's probably not the best strategy in most situations. So what works even better, so that I can get that antigen material inside of you, is that I take that whole organism and I kill it. Then it can't hurt you, right? But it'll have all the information for your immune system to be able to identify it. So, therefore, you're going to go through the whole process of macrophages eating it, antigen presentation, bringing it to the dendritic cell, bringing it to the T cell, bringing it to the B cells, then having it as memory cells to go and store information for now and into the future about how to kill that pathogen. 10 seconds. And there's a few other ways too. We'll talk more about this. a little bit. For instance, sometimes a whole live microorganism isn't actually as bad as you think. Who has ever heard of something called smallpox?